Hey everyone. So we want to talk at the beginning of this polynomials unit about graphing quadratics three different ways because there are three different forms. There's our general form, y equals ax squared plus bx plus c. There's our standard form, y equals ax minus h squared plus k. And you might think of this as, ooh, that's in transformation form. We're transforming an x squared graph. And we've also got intercept. And it's called intercept, but it's really x-intercept form, where we see this parabola factored, x minus b, x minus c. These are our three forms, and I recommend that you write them into your notes. Maybe you want to pause this video and do that. And I'm going to ramble on for a minute or so here and say, one of the things that as an Algebra 2 teacher I had to spend time doing was teaching kids how to go from this form to this form or this form to this form rather than just graph from whatever form they have. And I realized that it was actually harder for students to go from here to here than it was just to teach them how to graph from here. So we would need completing the square to go from this to this, and it would be nasty and unpleasant. And so I'm not going to teach you that method. Instead, I'm just going to show you how to do quick graphs, quick, accurate graphs from general form, from standard form, from x-intercept form, without having to rewrite any of these, okay? All right, so the first thing we need to remember, and I hope we remember this from Algebra 2, is that the vertex, it went from general form, is located when x equals negative b over 2a. This really does come from the quadratic formula, and the quadratic formula comes from completing the square on this. And if we have time, we'll take a look at that. But really, I think your time is precious, and I want to make sure we have time for the word problems at the end, which are generally more scary and motivating for you than wanting to see where this thing comes from. Though it's kind of nifty, it is the, we've got negative b plus or minus square root b squared minus 4ac all over 2a. Well, that is the x-coordinate of my vertex. So there's the x-coordinate of the vertex. But how do you find the y-coordinate of the vertex? Well, you would have to take this, fraction, and plug it in for all these x's to get that y value. And that's kind of the most pain in the butt we've got in this whole graphing extravaganza that we're going to do today, is finding the y value for this x value. Okay, so we're going to start with general form. From general form, y equals ax squared plus bx plus c. All right, so step one. Find the vertex. Well, we know the vertex is located at at negative b over 2a, comma, how do I find the y value? Well, I have to plug this into that function. So the function evaluated at negative b over 2a. Don't get scared about this notation. I'll go through it in a minute. I'm just laying out what we're going to use. So the first thing we're going to do is find the vertex. The second, we're going to find the y-intercept by plugging in 0 for x. Psst. When I plug in 0 for x, all I get is c. The y-intercept will always be c in general form. Not in the other forms, just in general form. So I recommend thinking about it in this manner. And we need a third point on our graph, and that third point is going to come from using symmetry. Okay? Symmetry. So let's take a look at a function that is in general form. I'll write one down here. We've got y equals 2x squared minus 4x minus 3. Okay, so from this form, I think I need to find the vertex. Well, the vertex is located at negative b over 2a, because there's my a value and there's my b value. Notice the b value includes the sign. So I end up with negative times negative, which is positive. 2 times 2 is 4, or 1. So the vertex here is located at 1. But wait a minute, what's the y value there? Well, this is where I said before we would need to plug this negative b over 2a, in our case 1, back into the function for all the x values to find the y value. So y is going to be 2 times 1 minus 4 times 1 minus 3. Or y equals 2 minus 7, or negative 5. So I know that the vertex is located at 1, negative 5. Great. Well, what else did we need? We wanted to have, for step 2, the y-intercept. There it is. When I plug a 0 in here, this goes away. A 0 in here, this goes away. And so my y-intercept is negative 3. Well, let's plot what we know. We know there's a vertex at 1, negative 5. That's my vertex. And then we know at negative 3, we have a y-intercept. Hey, you might want to make a note in your notes at this point that commonly, the most common mistake when kids do this is they now graph like this. This is not the vertex. This is the vertex. This parabola doesn't point down. This parabola points up. This student has misdefined the vertex. The vertex was at 1, negative 5, and the parabola points up. So my graph needs to look like this. Okay, we've got 0, negative 3. We've got 1, negative 5. Now I need a third point, and I set up here that I would use symmetry to find a third point. Well, there's an axis of symmetry in every parabola, and we're going to make use of that. What's the distance from x equals 0 to x equals 1? What's this horizontal distance from 0 to 1? So what would be the distance, because of symmetry, from that midline out to this other point? Well, that distance, because of symmetry, would have to be the same. So 1 plus 1 tells me that this is 2, and the y value here is the same as the y value here, negative 3. So there's my graph, all without having to do any completing the square. Let's do another one, just to get a little more comfortable with this. Again, I recommend writing these into your notes so that you have them. Y equals 3x squared plus, I kind of want to do negative. No, we'll wait on that. Plus 12x plus 5. Okay, so I'm looking for the vertex at minus b over 2a. I know that the x would be minus b over 2 times 3, which is minus 12 over 6, or minus 2. How do I find the y coordinate of the vertex? Well, I have to plug this x back into the function. 3 times negative 2 squared plus 12 times negative 2 plus 5. So negative 2 squared is 4. 4 times 3 is 12. Here I have negative 24. Here I have plus 5. So negative 12 plus 5 is negative 7. The vertex is located at negative 2, negative 7. We can see that the y-intercept is 5. When I plug a 0 in here and a 0 in here, I get 5. So we know we're also going to pass through 0, 5. Okay, well, let's graph this. We've got negative 2, negative 7, and we've got 0, 5. Again, this is not our vertex. This is our vertex. Our parabola points up, so we want to draw something that looks like this. We know there's this midline that runs through the graph. What's the distance? In order to find the third point, what's the distance, horizontal distance, from the vertex to this point? Well, from -2 to 0, we've got 2. So we're going to go 2 more in this direction. Maybe we should call these -2's. Whatever this amount is, this amount has to be the same. So the total distance here from this y-intercept is going to be -4. And the y value at these points are the same. Any questions about using symmetry here, you should send to the group me and I'll answer them. But we're going to be using symmetry a bunch here to help us speed up this process. So again, from general form, I'm going to need 3 pieces of information. I'm going to need where the vertex is using -b/2a and plugging that number back into the function. I'm going to need the y-intercept, this one here, and then I'm going to use this axis of symmetry and this distance being the same to find a third point with symmetry. Okay? So that's graphing from general form. Now, we're really happy to do that because then we don't have to do completing the square. Next, we've got, Next, we've got standard or vertex form. Okay, so this is y equals a x minus h squared plus k. We know that the vertex is at hk. Think about it this way. Think in terms of transformations from our time in August. What have we got here? We are shifting to the right or left, depending on whether we have a positive or negative here. And we're shifting up or down, depending on what our value of k is. So these are the shifts of our x squared graph. So our vertex will be at this new point. Wherever we shifted left or right and up and down, that's where our new vertex will be because our vertex was originally at 0, 0. When I graph from standard or vertex form, it's called standard form because this is the way we most often prefer to have the parabola written for graphing purposes. It's most common that we'll see it this way or we want to see it this way. But it's also known as vertex form because we can read the vertex off the equation. And that's going to be the first thing I want to plot. And then, what did we just do when we were graphing from general form? We used the y-intercept, and step 3, we used symmetry for a third point. Okay, so when we're graphing from standard or vertex form, when the equation looks like this, we're going to identify the vertex. We're going to plug in a 0 for x's. Now notice, this time, it's not just this number. So you really do need to plug in 0 for x's this time, finding the y-intercept. But symmetry, finding the third point with symmetry, will be done the same way. You might want to pause the video and finish writing this into your notes. I'm going to erase this now and set up our next problem so that we can actually start graphing from standard form. Oh, I wish I hadn't erased that. Okay, so from standard or vertex form, we want to A, identify the vertex, B, we want to find the y-intercept by plugging in 0 for x's, and C, we want to use symmetry for a third point. Okay, so here's a parabola for us, 3x minus 2 squared plus 1. Well, I identify the vertex. Since we're looking at vertex form, x minus h squared plus k, I see that my h value is 2. Please note there is a minus in this equation. H is not negative 2. H is, in fact, just the thing behind the minus sign. H is 2. K is 1. So we know the vertex is located at 2, 1. Okay. Now, what happens when I plug in a 0 for x's? Y-intercept would be 3. 0 minus 2 squared plus 1. Okay, so that's going to be 3 times negative 2 squared is 4 plus 1. I get 13. The vertex is located at, the y-intercept is located at 0, 13. And then we're going to use symmetry, but I generally don't like finding that third point until after I've graphed the first two. So let's take a look at the graph here. We know that we've got a vertex at 2, 1. We know that this parabola points up because our a value is positive. And we know that our y-intercept is at 0, 13. Up-pointing parabola. Axis of symmetry. How far is it from here to our axis of symmetry? Well, the x value here is 2. This distance is 2. So if I go the same amount further, 2 more, I'll now have the same y value that I did over here at the y-intercept. So my coordinates here will be 2 plus 2, or 4, comma 13. Okie doke. Again, you may want to pause this and finish copying it down before we do the next one. Our next one is y equals negative 2 x plus 1 squared minus 3. All right, so what am I supposed to do? Identify the vertex. All right, well look, my formula has a minus here. Remember, x minus h squared plus k. A equals. All right, so what do I know? I know that k is now negative 3. The y value at the vertex is negative 3. But what about here? What number must I have plugged in for h so that I see a plus 1 here? Well, there's a minus here, and I see a plus here, and I must have plugged something here that changed this sign. I must have plugged a negative number in here. So my h is negative 1, and my k is negative 3. Okay, so we know that the vertex is at negative 1, negative 3. What about the y-intercept? What happens when I plug 0 in for x? Okay, I'm going to have negative 2, 0 plus 1 squared minus 3. And so I get negative 2 times 1 minus 3, and I get negative 5. So 0, negative 5 is my y-intercept. Again, oh, I wish I hadn't done that. Let me write it down again. Y equals negative 2, x plus 1 squared minus 3. Okay. Again, I see a lot of students who graph this way. They say 0, negative 5. They say negative 1, negative 3, and then they graph this. But no, look, my a value is negative. This parabola has to point down, not point up. Where's our vertex? Our vertex is here. This has got to be the lowest point or the highest point. So, let's think about this again. We've got this point here called the vertex at negative 1, negative 3. And we've got this point here at 0, negative 5. And we know our parabola points down. Our parabola goes down from the vertex. Now there's this axis of symmetry, and this distance, negative 1, would be the same as this distance, negative 1. So this ordered pair over here is going to have an x value of negative 2 and the same y value as our y-intercept. Okie doke. So that's graphing from standard form. You know, some of you are really comfortable with transformations, and if you want, you can do this problem with transformations. You know, negative 1, 1, 0, 0, 1, 1. We're going to subtract 1 from all the x's. We're going to multiply the y's by -2. We're going to have -2, -2, 0, oops, sorry, -1, 0, and 0, -2. Don't forget you have to subtract 3 from not the x's but the y's. And so we end up with -2, -5, -1, -3. Oh, there's our vertex. And 0, -5, there was our y-intercept. So I get the same ordered pairs. Sometimes I don't, but I'll get the same graph. But in this case, I certainly get the same ordered pairs. And you can feel free to use these transformations instead of these 3 steps when we're going from standard or vertex form. Okay, now, what about our last form, intercept form? So, intercept form is y equals a, x minus b, x minus c. Okay, so we know that x equals b and x equals c are x-intercepts. And so I already have 2 points given to me when I'm looking at intercept form. So I'm going to graph those 2 points, and then I need 1 more point. And we've got 2 choices that are easy and easier. Easy would be, let's find the vertex. We know that the vertex must be halfway between the x-intercepts. So I want to average these x-intercepts, b plus c divided by 2. This will get me some number. I take that number and I plug that number back into x to get the y value of the vertex. The y value of the vertex comes when I take this x value, the average of the x-intercepts, and plug that back into the function. But even easier than finding the vertex is finding the y-intercept. Because for the y-intercept, I just need to plug 0 in for x's. Okay? And we'll take a look at both of those options as we graph. But remember, from intercept form, I'm first identifying the x-intercepts. Remember, there are normally minuses here. And then I'm going to either find the location of the vertex, or I'm just going to plot the y-intercept. In intercept form, like in all the other forms, it's important to pay attention to whether a is positive or not. When a is positive, my parabola is going to point up. And when a is negative, my parabola points down. So pay attention to your a values. That's definitely a thing when you think you're done graphing. Make sure, go back and look to make sure that your shape has the appropriate sign for its a value. Okay, so let's take a look at graphing from intercept form. I've got y equals 2 x minus 1, x plus 3. So someone has already factored from general form, and now we're looking at this. Well, I see that x minus 1 equals 0 when x equals 1, and x plus 3 equals 0 when x equals negative 3. So I've got x-intercepts at 1 and negative 3. Okay, so I'll plot 1 and negative 3. Now, what's halfway in between those? Negative 3 plus 1 divided by 2 is negative 2 over 2, which is negative 1. I'm going to take a negative 1 and plug it in for these x's. So 2, negative 1 minus 1, negative 1 plus 3. It's going to be 2 times negative 2 times positive 2, which is negative 8. So I know the vertex is at negative 1, negative 8. And that wasn't so bad. You know, you've got to be a little careful here, adding these two numbers together and remembering to divide by 2. And then you just plug that number into this factored form. So I could say here, negative 1, negative 8 is going to be the location of my vertex. and that was 3 points. 2 x-intercepts from the factored form, and then halfway between those x-intercepts was the vertex. But remember, I said even easier than plotting the vertex would be plotting the y-intercept. Okay, so where's my y-intercept? Well, to find a y-intercept, I plug a 0 in for x. Look, I said it was only easier. Not easy, right? I mean, it's just, I'm going to have to plug a -1 in here to find the vertex. I'm going to have to plug a 0 in here to find the y-intercept. So what will that look like? 2, 0 minus 1, 0 plus 3, and I get -6. So 0, -6 is the y-intercept. I've got an x-intercept of 1. I have an x-intercept of -3. And I need a graph that passes through those points. So there's 3 points on my graph. 2 x-intercepts given from the factored form, and a y-intercept by plugging 0 in for the x's. Finding the vertex really wasn't that big a deal, though, was it? Right? I mean, it was just a matter of averaging these two numbers, averaging the x-intercepts, that's what we did here, and then taking that x value and plugging it into my function, which is what I did here. I was able to get the vertex -1, -8. You do not need to give me all 4 of these points, though you're welcome to if you like. That just may be a little more time consuming, and I think many of you spend too much time on your homework already. All right, we'll do one more of these. So how about y equals -4, x plus 5, x minus 3. Okay, so I see that the x-intercepts are located at x equals -5 because inside is opposite land, and x equals +3 because inside is opposite land. Now, what about my vertex? Well, what's halfway between -5 and +3? Well, that's going to be, again, -2/2 or -1. No, the vertex isn't always at -1. I just picked some problems where these distances were the same as the distances in the last problem. So I know the x-coordinate of the vertex. I'll plug that back in. I'll have -4, -1 plus 5, -1 minus 3, which is -4 times 4 times -4, which is +64. So my vertex is located at -1, +64. What about my y-intercept? If I plugged a 0 in here and a 0 in here, I'd have -4 times 0 plus 5 times 0 minus 3. Or -15 times -4 is +60. So if I go to graph this, I have intercepts at -5 and +3. I know this is a down-pointing parabola because my a value is negative. I have that negative a value, so I know my parabola has to come down through these points. The vertex is located halfway between them at -164, and the y-intercept we found was at 0, 60. Okay? So there's 2 examples of each of our types of graphing, from general form, from vertex form, from intercept form. You know, old school was they made students go from this form, 2x squared minus 4x minus 3, and turn it into y equals ax minus h squared plus k. And let's just take a look at that for a moment to see what that would be like. I have to use completing the square here. So I'm going to have y plus 3 equals 2x minus 4x. Remember, with completing the square, not only do I isolate the x stuff, but I have to turn a into 1. So I have to divide everywhere by 2. I have y plus 3 over 2 equals x minus 2x. Now I'm ready to add my magic amount to both sides, which is b over 2 squared. So I've got -2 over 2, which is -1 squared. So I'm adding 1. Over here, this factors as x minus 1 squared. Remember, we just bring this down. Over here, oh my god, I got so much crap. Pardon my language. So now I have to solve this equation for y equals. I need y by itself. So I have to undo all this stuff I just did. I'm going to have to subtract 1 from both sides. I'm going to have to multiply both sides by 2, which means multiplying everything by 2. And most students forget to multiply by 2 over here. They're so busy multiplying by 2 here. And so now we've got y plus 3 equals 2x minus 1 squared minus 2. And then finally we subtract 3 from both sides. So if I subtract 3 and subtract 3, I'm going to have y equals 2x minus 1 squared minus 5. Now I'm ready to start graphing. That's crazy. Now all that work just to get me into vertex form when I could be done with the problem already, because I know minus b over 2a finds the x-coordinate of the vertex. There's my y-intercept, and I use symmetry to find a third point. So you can use completing the square here to rewrite this, but really I wouldn't. Though I would say, as I did before, that out of curiosity, if you started with y equals ax squared plus bx plus c, and you wondered, hey, I wonder what the x-intercepts will be for this. Well, let's do completing the square here. We'll subtract c. And remember, this has to be equal to 1, so I have to divide by a, divide by a, divide by a. So now I've got minus c over a equals x squared plus b over ax. Now, what was it that I needed to use to complete the square? B over 2 squared. So plus b, this is my b value, b over a over 2 squared. Well, when I'm doing this, we learned with complex fractions, that was the same as doing b over 2a. And if I square this, I'll now be looking at x squared plus b over a. Actually, I don't need to square that, do I? Yes, I do. B squared over 4a squared, right? Because I have to square the b, I have to square the 2, I have to square the a. All right. And then I know that this, no, I didn't want to do that after all. Sorry, I'm changing my mind again. I'm going back to this last step, and I'm saying this turns into that nifty factored form. Remember, x plus, there we go, b over 2a. Okay, so what now? Well, remember what we're trying to do is we're trying to solve this for x. We plugged in a 0, and we want to know what x equals. So I have to solve this equation for x, which means now taking the square root of both sides. Oh, I didn't add my b over 2. That's where the problem was, Mr. Kukla. Please note, Mr. Kukla added b over 2a squared to one side, but not to the other side. Okay, so this is going to be on the left side, minus c over a plus b squared over 4a squared. Now, I'd like to tidy this up into one fraction, and so I'm going to have to make a common denominator. I'm going to need to multiply the top by 4a and the bottom by 4a. And so now I'm going to have minus 4ac plus b squared over 4a squared. And you might want to write that in the more familiar b squared minus 4ac over 4a squared. Okay, so let's get back on track. The left side of this equation now looks like b squared minus 4ac over 4a squared, and the right side of the equation looks like x plus b over 2a squared. We take the square root of both sides. What am I supposed to remember when I take the square root of both sides? the plus or minus. And so now I've got plus and minus square root b squared minus 4ac all over 4a squared equals x plus b over 2a. Well, I'm trying to get x by itself, so I have to subtract b over 2a. And so now I've got x equals negative b over 2a plus or minus square root b squared minus 4ac all over the square root of 4a squared. What's the square root of 4a squared? 2a. Look, I have a common denominator. So I can write this as negative b plus and minus square root b squared minus 4ac all over 2a. And so the quadratic formula was born. The quadratic formula just comes from using the completing the square on solving a general form quadratic, setting that general form equal to 0 and solving. Okay? All right, so we're almost done. I need to get in for you 2 word problem examples. I think you're going to be much happier if we do these than if we don't do these. So let's do these so that you have a chance of being able to do them on your own. Okay, so we're told in the directions of the problem, we're looking for, or we know that the product of 2 numbers is a maximum. Huh? What does that mean? Well, it's as big as possible. But then they tell us in the specific homework question, the sum of these 2 numbers is 24. Okay, so the sum of 2 numbers is 24. X plus y equals 24. The product, remember product means multiply, so x times y is as big as possible. Okay, so what can we do here? Well, I've got a little product equation. Product is x times y, but I notice that my product equation is in terms of 2 inputs. I would really like product in terms of just 1 variable. So I'm going to use this from what they gave me in the homework question as a helping equation. And I'm going to solve this equation for y equals. I'm going to subtract x from both sides and get that y equals 24 minus x. And I'm going to replace this y over here with this 24 minus x. So my product equation is now x times 24 minus x. Let's go through that again. We knew that the product was going to be the multiplying 2 numbers together, but our product was in terms of 2 different variables. So I wanted to get product in terms of 1 variable, which meant I had to use this other piece of information equation, which I'm going to call a helping equation, to help me get rid of y and replace it with some x stuff. What x stuff? Well, when I subtract x from both sides here and get y by itself, I see that y is 24 minus x. So I can replace this y with this x stuff. Now, why do I want to do that? Well, I see factored form already, or if I distribute, I have negative x squared plus 24x. I can think about this graphically. I know this parabola points down. I know it has intercepts at 0 and 24. Well, let's think about that. Here are my products, 0, 24. Where's my maximum occur? Well, I know my maximum occurs halfway between the x-intercepts. So halfway between 0 and 24 is going to be 12. When x equals 12, the product is a maximum. So I know x is equal to 12, but what's y equal to? Well, remember over here from our helping equation, y is 24 minus x. If the x that produces the maximum product, the highest product of these 2 numbers, is when x is 12, then I plug a 12 in here. 24 minus 12 is 12. And so I know those numbers must both be x equals 12 and y equals 12. Okay, that was doing it from intercept form graphically, but we could also go from general form using minus b over 2a to find that x value. So minus 24 over 2 times 1, minus 1. And I end up with positive 12 again. And again, if x is equal to 12, I know that y is 24 minus 12, and so y equals 12 as well. So those two numbers are going to be 12. Okay, well, let's try a different spin on that. I'm still looking for the product of two numbers as a maximum, but this time I'm going to say the first number plus 2 times the second number is 36. Okay? So this time my helping equation looks like the first number plus 2 times the second number is 36. And I still have the product is x times y. And I still feel like, well, product isn't in terms of one variable, and I really need product in terms of one variable. So I'm going to go back to my helping equation, and I'm going to solve this helping equation. You know, it doesn't matter if you solve this helping equation for x or y. Let's solve this helping equation for x. X equals 36 minus 2y. So this time I'm going to have product in terms of y's. Okay, so now I'm replacing x with what x is equal to, 36 minus 2y times y. And what do I have here if I distribute negative 2y squared plus 36y? Another downturn parabola, which will have a maximum on it. That vertex is going to be a maximum. And if I think about it graphically, here's my product. Now this isn't the x-axis anymore. Its product is a function of y's. And I've got y-intercepts at 0. And where's this y-intercept going to be? 36 minus 2y equals 0. 36 equals 2y. And divide both sides by 2 to get 18. So this is at 18. And I know my vertex is halfway between 18 and 0, so 9. When y equals 9, we have our maximum product. Well, let's take that 9 and plug that 9 back in here. 2 times 9 is 18. 36 minus 18 is going to be 18. So the numbers are x equals 18 and y equals 9. Let's try that again. X equals 18 when we plugged 9 back in here, and y equals 9. But remember, we could also do this using minus b over 2a. Y equals negative b over 2a, and so we're going to have negative 36 over 2 times negative 2, and I'm going to have 36 divided by 4, which is 9. I'll plug that 9 back in and get x equals 36 minus 2 times 9, or 18. Okie doke. So use that helping equation. I can hear one of you saying, Mr. Cooper, I find it very confusing to have these y's. Why didn't you do it with x's? Why did you solve this helping equation for x? I'll show you why now. So let's solve this for y equals. Okay, so I'm going to subtract x from both sides, and I'm going to have the 2y equals 36 minus x, and now I divide everywhere by 2. And I get y equals 18 minus 1/2 x. So when I plug this back into product can now be in terms of x's, the way many of you like, but it does have a fraction in it, which some of you don't like. I can still graph this, but finding the x-intercept here is a little more challenging. I know I have an x-intercept at 0, so let's take a look at this one. 0 equals 18 minus 1/2 x. I'll add 1/2 x to both sides, and then I'll multiply both sides by 2 and get x equals 36. So I know my intercepts are located at 0. and at 36. It's a down-pointing parabola. If I distribute this x, I have negative 1/2 x squared plus 18x. I see it's a down-pointing parabola. And I know that the vertex occurs halfway between these intercepts at 18. So when x is 18, we have a maximum product. If I take that x value and plug that x value back in, so to find y, 1/2 times 18 is 9. 18 minus 9 is 9. And so I get the same y value that I did before. Y equals 9 with the same x value. X equals 18, whether I made this product as a function of x or product as a function of y. Okay, last problem we need to look at is a corral. You know, the nice thing about living in Tucson, especially on the east side, is you may actually know people who have horses. And in this case, we're looking at a situation where we have a corral where this is an overhead view, where these sides are all the same length, and they're called y, and these lengths are all x, okay? We've got 288 feet of fencing, and that fencing needs to go here, and here, and here, and here, and here, and here, and here. So that's going to be 4x's plus 3y's. And what we're trying to do is give the horses the maximum area possible in these corrals. So I see that this shape is just a big rectangle, and the formula for area of a rectangle is length times width. Well, what is this length? If this amount is x and this amount is x, Aya says that x plus x will be 2x. So I know our rectangle has a length of 2x and a width of y. So here's my area function, 2x times y. But again, just like in the last problems, this is not in terms of one variable. So I really want to get a in terms of one variable. Uh-oh, I need to get rid of y. Luckily, I have perimeter as a helping equation. So we need to solve this equation for y so we can replace this y with some x stuff. So this is going to be 288 minus 4x equals 3y, and then we're going to divide by 3 and divide by 3. Okay, is 288 divisible by 3? 16 plus 3 is 19, not evenly, so I'm not even going to try and do that. I'm just going to replace y with 288 over 3 minus 4/3 x. Okay, so there's our area function. And again, if we distribute, we'd have 288 times 2 is 576. We'd have minus 8/3 x squared plus 576 x over 3. Great. But what I do see here is that area is a down-pointing parabola. And I see one of my zeros is at 0. And I see there's going to be a maximum area. And that maximum area, I can find it one of two ways. I can find this x-intercept by setting this equal to 0 and solving, and then finding halfway between those x-intercepts to get that x value. Or I could do minus b over 2a with my general form. So let's take a look at these two options. Again, one of them was that we should take negative 8/3 x squared plus 576 x over 3, and we should do minus b over 2a here. So x equals minus b minus 576 over 3 over 2 times a, which is negative 8 over 3. So that's negative 576 over 3 over negative 16 over 3, which is negative 576 over 3 times flip and multiply 3 over negative 16. So is 576 divisible by 16? It sure is, 36 times. So I know when x equals 36. When x equals 36, or the whole side is 72 feet long, we're going to have maximum area. But oh, by the way, the homework question says, what are the dimensions of this corral? Well, we know that this is 36 feet, so 2 times 36 is 72, but we still need to find y. How can we do that? Well, remember we had this helping equation that said y was equal to 288 over 3 minus 4/3 x. So we're going to have to plug in our x value of 36 in here. So 288 over 3 minus 4 over 3 times 36 equals our y value. This is the way I have to find the y value. Well, I can see that there's a little simplifying here. And so I'm going to have 288 over 3 minus 48. You know, I kind of wish we had the common denominator, so I'm not actually going to do that canceling. I'm going to keep it and say 36 times 4 is 144 over 3. And so 288 over 3 minus 144 over 3 is 144 over 3 feet. Okay, and 144 divided by 3 is conveniently enough 48 feet. So I know that if this is y, then this is 48 feet. And if this is 36 feet because it's x, and this is 36 feet because it's x, the whole thing is 72 feet. Okay? So, let's hit the highlights of that. Oh, wait, I wanted to go back and do this one not with minus b over 2a, but from the factored form. I wanted to use this form, 2x 288 over 3 minus 4/3 x. Okay, so we know that this is a down-pointing parabola, and we know this is at 0 because of this. But what about this one? We have to set this factor equal to 0. So 288 over 3 minus 4/3 x equals 0. I'll add 4/3 x to both sides, and I'll get 288 over 3 equals 4/3 x, and I'll multiply both sides by the reciprocal of 4/3, 3 over 4, 3 over 4. And so I get x equals 36. And once I know what x equals, I still have to go back to that helping equation. Remember, y equals 288 over 3 minus 4/3 x, and I'm going to have to plug that x back in there. Y should still be 48 feet. I'm merely showing you that you can either find the ordered pair for the vertex by averaging the x-intercepts to get the x-coordinate of the vertex and plugging that back in to find y, or you could go from general form and do minus b over 2a. Okay, well, it seems my voice is giving out now, so I think this is a great time to stop. We went through 2 scary word problems. I derived the quadratic formula for you. You're not going to have to derive the quadratic formula on a test. I'm sorry, Nathan. But I do need you to be really, really, really comfortable graphing those quadratics, whether I give you general form, which was ax squared plus bx plus c, whether I gave you standard or vertex form, which was ax minus h squared plus k, or if I gave you intercept form, which was y equals ax minus b, x minus c. Okay, so those are the 3 forms you need to be comfortable with. Please, 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 please imagine there's a quiz coming your way, perhaps even a CFA, where you have to graph from each of these forms. You're going to need to be able to do this. So please make sure you practice this with the homework, do these problems, practice this again, watch the video again, send questions to the group me, make sure you know this stuff, and have a wonderful day.